Hello, I'm contestant number 14761, and we're Team K of the Additive Manufacturing Contest. I will be starting off this presentation by showing our initial thought process behind this product, and also our initial design process. My team partner later on will show the manufacturing process behind this product, display how to use 3D printing technology, and some of the difficulties we encountered when turning our design into reality. Let me explain our initial thought process behind this product. I had recently purchased a Fitbit Luxe smartwatch to track my workouts, and this is the charger it came with. I quickly noticed a big problem with the charger. When charging, it holds onto the smartwatch via magnets inside the charger. However, these magnets are sometimes not strong enough to keep the smartwatch charging. Also, I had almost lost the smartwatch many times because of the charging situation. The charger could not stand up by itself, so the smartwatch had to be laid on its side when charging, making it even easier to lose or damage by accident. I began thinking about how I could fix this problem by making some quick sketches of possible solutions on a piece of graph paper. Here you can see I modeled the charger itself, then a holder, and a stand for it, so that I could charge the smartwatch standing up. Also on the bottom here, I would like to note that I thought about how to possibly 3D print the design as an all-in-one assembly, so that anyone could just take it off the printer, remove some supports, and immediately use it. However, we ditched the setup in favor of printing the product in 3 separate parts, as it yielded much cleaner results, and I made sure assembling the parts together in the end is super easy and very satisfying. Moving on to the CAD, I modeled the product in Onshape, a web-based CAD software, because I only had a Chromebook and a mouse at the time. The first thing I did was turn the actual charger into a 3D model by taking dimensions of it with some calipers and using photos, such as this one, as references. I then designed a holder around the model of the charger so that I could lock the charger in place. I used a friction fit hole and put the wire through it to keep the charger in the holder, and walls on the sides of the charger to prevent it from rotating. After designing the holder, I immediately printed it out on my 3D printer to see if the Fitbit charger would actually fit. I threaded the wires through the slot and stuck it through the hole. The holder held the charger perfectly. After that success, I returned to Onshape to model the stand. I started modeling by extruding a basic rectangular block. I then added a slot for the holder and a hole for the wire. Later on, I would make the holder and this part in an assembly and print both out as one part. I then added a block here for aesthetics purposes and to help support the smartwatch when it is charging. I hollowed out a large part of the original extrusion to save material and weight. After that, I added this rod structure here for the other parts to hinge off of it, as you will see later. I then started designing the base of the stand, attached it to the other part by giving a circular slot to snap into the rod structure as mentioned previously. The simple hinge structure would be easy to print on a 3D printing CNC and is cool to assemble together after printing. Here you can see I modeled a similar rod structure in the back of the base plate for the hinging stand that I will model later. I cut the middle portion out of the base to save weight and material as well, making sure to put fillets everywhere for aesthetics and to give the product a good feel. Finally, I modeled the last part to hold everything together. I made it simple and easy, giving it a slanted shape so it could fit easily inside the grooves I modeled earlier on the back of the first part. After all that, I imported the parts into an assembly and mated them together properly to check for fit and style. One of the assemblies I had the stand open, and in another one I had it in its folded or closed position. I was really happy and satisfied with this look, so it was time to take the model to the slicing software for 3D printing. Just a quick thing to note as well, these tabs here were actually designed later after printing out the first prototype. They give the stand another great function, and that is to hold any smartphone in its vertical or horizontal position.
So to set up the slicer settings, first we chose 0.15mm for the print layer height, since our design did not need to be very detailed. And we selected the filament as overture filament, which is what we're printing our design with. We added supports because our design had bridging features, and we used 25% infill since it won't undergo much force, and it will also save on printing cost and time. After we sliced the model and exported its G-code, we are ready to put it into a USB drive and take it to the 3D printer for printing.
This quick portion of the video is a sped up screen recording of me exporting all the parts of the design as STLs and then importing them into the slicing software. Here I am properly orientating the parts for printing and spreading them out on the printing bed so the 3D printer can print them properly. Here is a quick time lapse of the first layer being printed on the 3D printer. As you can see, everything turns out great and the print settings are spot on. After the printing is finished, we take off the support structure, and after that is done, the parts are ready to be assembled and tested. The assembly is pretty simple and straightforward. The two hinges just have to be clipped together. The product works amazingly as both a Fitbit charging stand and as a phone stand. Thank you very much. This is Team K. Have an excellent day.